equals 20 kilometers in real life. Yes, Mr. Tacky.
I'm not really good at kind of understanding kilometers. Like, from here to, let's say, Polo Park.
Yes.
How many kilometers might that be?
I'm guessing like 7-ish. Ish.
That's a lot more.
Yeah. What's the length of a basketball court?
I don't know, but it only takes me about 4.5 seconds to get inside.
Takes you that long? Wow, you're slowing down. You're slowing down there in your old age. Let's go back to part A. Part A wants you to actually measure the distance from the center of Winnipeg to Portage la Prairie. So we're just going to estimate where the center is. Portage la Prairie is right here on the map. And so let's measure the shortest distance. We estimated right in the middle. Offer for a measurement? Confirm. 7.2 if you're a little bit off in the center, that's fine. Can we go with 7 just so it's a whole number?
How about 7.1?
You want to go 0.1? Part C is the math that's involved in this. It wants to find and that should be actual distance, not actually distance, actual distance from Winnipeg to Portage la Prairie. All the questions are going to work in the following ways. We're going to set up two fractions that are equal to each other. I'm going to start with the scale factor that's in the question. So 1.7 over 20. And off to the side, I'm just going to note the top number is centimeters, bottom numbers is kilometers. We measured 7 on the map, and we want to know how many kilometers that is in real life. So all we're doing is setting up two little equivalent fractions. This is now an equation, so we're back in Unit 4. We spent a whole unit solving equations. How do we solve equations? Mr. Tacky, yes. Kind of excited here. I was actually hopeful you knew, and now you've kind of disappointed me.
You can ask her.
Okay, Matt? By? Good. So what's the opposite of dividing by x? Timesing by x. Now I'm going to show you a little trick that's going to do this in 2 steps instead of 1, and sorry, 1 step instead of 2, and you probably saw this in grade 8, is we're going to do what's called cross-multiplying. Have you seen that before? Okay, so what it's going to do is just reduce a step in solving our equations. So cross-multiplying says we take 1.7 times x, which is? Excellent. And now on the other side, we take 20 times 7, and you can do 2 times 7 and then add the 0. I kind of heard it, but didn't really hear it. This was the last step in every single equation we solved in Unit 4. How do we get rid of a coefficient of x? Divide by it. This would now be a calculator question. If we go to 1 decimal place, can I put 4? Confirm, 82.4. Yes, Mr. Tacky?
I'm confused.
Always.
Why did you say it's a calculator question? The answer is 82.4.
You know, don't make the children feel bad because they don't have your brain power. Yes. Don't make them feel bad.
I don't understand.
I know.
Oh, okay.
What are the units? So what did we just measure in? We measured in centimeters, but we're calculating kilometers. The questions are all going to work this way. You're going to set up your two fractions. You're going to cross multiply. You're going to divide. Every single question will be exactly the same. For today. Yes, Mr. Tacky?
So if I go on to, like, I don't know, not that Google knows everything, but if I go onto Google and
Yes.
say distance between Winnipeg and Portage la Prairie, it
It would be very close. Not possibly, it would be.
Let's roll.
Kind of excited.
Is it all right if I'm doing
Yeah,
this?
yeah, yeah, I'm excited.
No one else do this. I want to do this. If someone else says this answer,
I'm kind of excited.
I'm not circuses. Oh, you're just playing a game? Okay. Okay. Go. Come on. Oh, I should go to maps. Goodness. Hi. Taking too long. Oh.
Number 2, this one time instead of giving you the map, they're just giving you the scale outright. These are the easier kinds of questions because you don't have to measure. They're telling you this particular map that we don't even have in front of us is 1 centimeters for every 200 kilometers. Calgary is roughly 1,400 kilometers from Winnipeg. How long would the distance be on the map? Show me, prove it. So we're going to start with the ratio, 1 over 200. And again, off to the side, I like just to write what the unit is because sometimes that makes it a little bit easier to set up the second fraction. Now last time we put the number on the top, but we're not going to do that this time. We're going to put the number on the bottom. Why? Because it's kilometers on the bottom and we're given an actual distance. That's why I like to write this off to the side. So kilometers are on the bottom. Annika?
Is kilometers always on the bottom? Like, does it have to?
It's whatever comes here. This is the top, this is the bottom. What goes on the top? What do we not know? Distance on the map. Okay, so the x will change just depending on what the question has asked you. Matt, did you have a question? I kind of heard something. Yeah. Okay. Cross multiply. 1 times 14. 200 times x. This now is like every equation we solved in Unit 4. How do we get rid of a coefficient of x? This would be a non-calculator question because the numbers are simple enough that you can just do it without. What's 14 divided by 2? And we need some kind of units. Well, the best way to figure out the units is see where your x is and see what's the units we wrote on top. So this means x has to be centimeters. Questions so far? On the same map, Winnipeg to Toronto is 22 centimeters long. What's the actual distance? We're going to start with the same ratio, 1 over 200, and that's centimeters over kilometers. Where is 22 going? On the top or on the bottom? Why on the top? Because it's centimeters. What's going to go on the bottom? X. So let's just review. Why did the x go on the top here, but it's on the bottom here? Because this one gave us kilometers, where this one gives us centimeters. Still cross multiply. 1 times x. 22 times 200, we'll do 22 times 2. 44, and then add the 2 zeros. Units, again, to get the units, figure out where x is. Look at the units that are right there. 4,400 kilometers. Show me thumbs. I'm getting this. I'm kind of getting this. Good. Read to read number 3. Don't overthink it. Just read it like it's a sentence in a book. Okay, what's important? So what are the 2 things we're going to have to draw in the box? The Earth and The moon. Can we draw them actually the physical distance they are apart? Clearly not in the paper. What the question is you figure out what's the scale so that it will fit inside this box. Well, let's start by drawing one of them. Do you want to draw the Earth first or the Sun first? The moon. I don't know why I said sun. Clearly that's Earth. Look how Earth-like that is. How do we determine a scale? How do we determine the scale? Well, if I divided this by 1, could I fit it in the box? If I divided it by 2, could I fit that in the box? So could I fit that number divided by 2 centimeters into the box? No. What if I divide by 3? So what's appropriate number I'm going to be able to divide by to fit in the box? So obviously a small number is not going to work. Give me a bigger number. Okay, 100. If I divide this by 100, can I fit 382.5 centimeters in the box? So 100 is too small.
1,000.
Okay, 1,000. Let's divide by 1,000. How many centimeters if I divide by 1,000?
382.
Can I fit 382.5 in the box? Okay, so 1,000 is too small. 10,000. Okay, if we divide by 10,000. Okay, well, let's start with 10,000. What's the number if we divide by 10,000? You all have calculators. You can all do this. 38.2. Can I draw 38.2 centimeters? Okay, so what does that tell you about 10,000? That is such an odd number. Why would you pick that number? Such an odd number. Okay, so 10,000 is too small. Pick another number. 20,000. Okay, let's divide this by 20,000. Can I draw 19 centimeters?
Yeah.
19 centimeters. Nope, not going to happen.
10 centimeters is the max.
Okay,
How about 10,000 centimeters?
we just did 10,000 centimeters. Okay, let's try 25,000.
Does that work? How about 2 centimeters?
How about we do one at a time? We're at 25,000. We're doing one suggestion at a time. We're still on 25,000.
Okay, guys. One at a time. 28,000.
We're still on 25,000.
We can't fit 25,000 centimeters.
How much? 15.3. Can we fit 15? Nope, so 25 is too small. 50, 30, 28. What do you want to try? Okay, 28.
13.
Can we fit 13.2? Really?
On the other side of the earth, you can't maybe.
We can't fit it here. Okay, let's do 50. Let's try that one.
11 exact.
7.65. Can we fit 7.65? So there's a great scale. What scale did we just choose? 1 centimeter is going to equal 50,000. Okay, so then we're taking 382,500 divided by 50,000. Can we go 7.7 if we round to 1 decimal place? Okay, so let's draw a line 7.7 centimeters long. Is 1 centimeter equals 50,000 the only possible answer? No, you could have a slightly smaller number and have the moon further out. You could have a slightly larger number, have it closer, as long as it fit within that box. Do you see how we used guess and check? Okay, we kept trying bigger and bigger numbers till we found one that fit in the box. Number 4, describe in words what this means. What does it mean?
1 centimeter is equal to
1 centimeter where on what?
a tenth.
That's not what I asked. Could you not randomly shout words, please? 1 centimeter on what? A map or a diagram?
We're past it.
Equals 0.1 centimeter in real life. Give some examples of something that could be drawn using this scale. Well, what do you know about the real life object? It's pretty small because we're making this actually larger. We're taking 1/10 of a centimeter and drawing it at a centimeter. So give me an example of a real life object that's pretty small. Sorry, Emily? I still didn't hear it. On a computer, a motherboard? So circuits? Circuits are tiny, teeny tiny. Atoms, I think you need a much bigger scale than that. Sorry? Oh, thank you. Think science. I think you need a bigger scale than that. They're pretty tiny. Insects.
This ruler.
I don't think you'd do it to that scale. Why would you make that a smaller scale?
Because it's really thin.
Yeah, why would you draw the thickness of your ruler? Okay, let's move on. Read to read. What's important? What else is important? Determine the appropriate scale factor. And draw the scale diagram. So I've purposely given you a fairly small space. So what does that tell you about the scale? No, if the space is small, the scale has to be big. Okay, so could we draw 4 meters by 2.5 meters in this box? No, a meter sticks over there in the corner. They're huge. So what's an appropriate scale? What can we fit within this box? 1 centimeter. So would you like to make 1 centimeter equals 1 meter? So if we use 1 centimeter equals a meter, what dimensions do we need to draw? 4 centimeters by 2.5 centimeters. Is that the only possible scale? No, we could have a different scale. We could have 0.5 meters. We could have 0.9 meters. As long as it fits in the space, there's lots of appropriate answers. And I'm just going to write down what we drew it as so when you look back, you know why we picked those values. It's a very tiny room. It's like a room for ants. Example 6, the same, except now we're going to do an enlargement. So you've captured an ant. Why people want to capture ants, I don't know. It's something with boys and bugs. I don't get it. I really don't get it. And we want to enlarge it using a scale diagram. The ant measures 3 millimeters by 2 millimeters. Determine the appropriate scale and draw the scale diagram. So we don't want to draw something that's 2 millimeters by 3 millimeters. It's too tiny, so we want a bigger scale. What's that? Offer of 1 centimeter equals 1 millimeter? Okay, so how big do we need to draw this guy? Okay, and it's not going to be rectangular, so I'm just going to start by measuring 3 and putting 2 little dots. And then I'm going to do the same with 2. I don't want to draw a rectangular because clearly ants aren't rectangular. What shape are they? They're like, what? I put an ant right there to help you. What shape are ants? They're circular. And how many circle sections do they have? They have 3. How many legs do ants have? 8. Uh-huh. I think 2 are antenna. I think you're right. Yeah, 6 legs and 2 are antenna.
Wait, what?
Let's take these off. 6 and antenna. And again, just like the last example, I'm just going to mark what we drew so when you look back, this was 3 centimeters, and this was 2 centimeters. Questions? There's some questions.